So I thought I'd do a couple of examples of how to use the counting principle to find the number of possible outcomes. So I'll do a couple from this worksheet here. Number 3, the map on the right shows the roads that lead from one town to another. How many different routes can you take while traveling from town A directly to town D? So if you notice, there's 3 options from town A to town B, 2 options from town B to town C, and 5 options from town C to town D. To set this up, here's what I want you to do. We know we're making some choices right here, so I'm going to put a blank line, and this is going to represent going from town A to B. Now we're making some choices here, so I'm going to put a blank line, and this is going to represent going from town B to town C, and then we're making choices here. So this blank line is going to represent going from town C to town D. Now it's just a matter of filling in the blanks. I have 3 options in this situation. I have 2 options here. And I have 5 options here. Multiply them together, and that's how many total possible outcomes there are. Or in this case, how many different paths you can take from A to D. 3 times 2 times 5, 30. Number 4 is a slightly harder problem. It says, Matt plans to assign 8 students to 8 desks for a debate. How many different seating arrangements are possible? So this isn't one of those problems where you can just take the numbers and multiply them together. You have to set it up. We've got 8 desks that we need to fill. So I'm going to start by writing out 8 blanks. This one's going to represent the first desk. Here's the second desk, third desk, fourth desk, and on and on until we have all 8 desks. Now it's a matter of thinking, how many options do we have for each desk? Well, I have 8 students, so I have 8 students to choose from for the first desk. But once I've filled that first desk, now I only have 7 students left to choose from for the second desk. I've filled 2 desks, so now I only have 6 students left for the third one, etc., etc. And you just keep going until you run out of blanks. There, I just filled in the last desk. And notice, when you get to that 8th desk, you don't have a choice as to which student goes there. Whoever's left over is going to go there. That's why we only have a 1 there. Multiply all these together, and that's how many total different seating arrangements are possible. This is going to end up being 40,320. Alright, we'll do one more. This one's license plates. It says in Washington, license plates have 3 numbers, followed by 3 letters. How many different license plates are possible? So, setting this one up isn't too bad, because we know we've got 3 numbers. 1, 2, 3. And these are all numbers. And then it's followed by 3 letters. 1, 2, 3. Letter, letter, letter. Okay? Now it's a matter of thinking about how many possible choices do we have in each spot. For example, in the first number, how many choices do we have? Well, I know we have digits 1, 2, 3, 4, 5, 6, 7, 8, and 9, but we also have 0. So we have 10 options there. For the second spot, because we can repeat the number that we put in the previous spot, so we still have 10 options. And we also have 10 for that one. Now, if we were not allowed to use the same number twice, notice it would go 10, then 9, then 8, because the number of choices would get smaller each time. When we get to the letters, we know there's 26 letters in the alphabet, so we can choose from those. And we can repeat the same letters, so we can put 26 here and 26 here. Multiply this all together, and that will show you how many total license plates are possible. This ends up being a huge number. 17,576,000 different license plates are possible.